Okay, so the first titration curve that we have to draw is 50 milliliters of 1 molar acetic acid with sodium hydroxide. So we have to get the pH at the initial, so we have to figure out where is all the H coming from, and I know that it's coming from the acid because that is what I am trying to analyze. So I write that equation there, and before I start, there's no reaction, and there's just this one substance here, so I don't need a Becca. All I need to do is do the ice. So I have it written out here for you. And once I have the ice, I can use that to solve for the initial pH. So we get x squared over 0.1, and that's the H plus, and then there's the pH. You could also do it maybe a little bit faster if you know what you're doing. And oh, never mind, you can't Henderson-Hasselbalch this because we don't have this number. So now that's the initial pH. So then we have to find the halfway, and the halfway is an easy one. When we're halfway to the equivalence point, pH equals pKa. So all we need to do is take the negative log of the Ka, and we've seen this one a lot because it's acetic acid. It's 4.74. Okay, then we come up to the equivalence point. So the equivalence point, at the equivalence point, I know that I have this many moles of acetic acid because I took my molarity times my liters. Molarity times liters gives you moles. So at the equivalence point, the definition of the equivalence point is that moles of whatever you're titrating, like analyzing, is equal to the moles of the thing that the titrant is what this is called. So 0.005 moles must be equal. I have two things on one side, so that tells me I better Becca. Every single time you are at the equivalence point, your after values should be 0. Okay? And it needs to add over here to the other side, so that's going to make this 0.005. Now, I could try to set up an ice, but then I would be subtracting from 0. So that doesn't make any sense. I have to take this, because this is the only substance I have, and figure out what equation I'm going to have here. So I'm going to have CH3COO minus plus water makes its conjugate acid. And OH. If you notice, we just took that equation and we flipped it around. Okay, now I'm ready to ice. We don't care about the water. There's none of this, and there's none of this. And what I need to do is 0.005, but I need to divide by the liters. So I started all the way up here with 50 milliliters. And I have 1 molar or 0.1 molar solution of both. So that makes this problem easy. 50 milliliters of this. At equivalence point, I'm also going to have 50 milliliters of the base. So my total volume will be 0.1 liters. I do want to warn you that on the test, these two values are not equivalent. If this one is, say, for example, twice as big, then we would need only 25 milliliters of base. Or if it was half the size, then we would need 100 milliliters of base. Okay? If that's confusing, you need to come see me. So now we ice minus x at equivalence is 0.005 divided by 0.1 minus x, which we neglect because 5% rule, plus x plus x. Now, I have the Ka, but this is a base. So I need to use the Kb, and that's going to equal x squared over 0.005 divide 0.1. And 0.005 divided by 0.1 is 0.05. And to find the Kb, I take Ka times Kb equals 1 times 10 to the negative 14th, which is the Kw. And I see 1 times 10 to the negative 14th divide 5.56 times 10 to the negative 10th equals x squared over 0.05. X is 5.27 times 10 to the negative 6. And the negative log of that is 5.27, and that is the POH because I'm at a base, and I need to take 14 minus 5.27 to get 8.72 is my equivalence pH. Okay, and then the last thing we need to do is after equivalence, and all we need to do is Becca. We have OH minus plus CH3COOH, and we had 0.005 moles. Let's say 60 milliliters. You can pick any point you want that's after the equivalence. So 60 milliliters of 0.1 molar would be 0.006, 0.001 remaining, and that would be divided by 0.11. POH equals negative log of 0.001 divided by 0.11. And that's going to give you 2.04, so the pH equals 11.95.